Hello, how's it going? In this little video, I'm going to have a look at sprite sheets and some of the math involved in calculating them. So let's say you have an object or a monster or an enemy or whatever, and they have an animation, but you want to approximate them from a bunch of different angles. If you go online, you'll probably find what's called a sprite sheet. It looks like this. Here we go. So as you can see, there's a single animation which has a number of frames, and that whole thing is repeated from a number of different angles. Now, just for the lingo here, I'm going to call these individual pictures frames, and this set of pictures I'm going to call a pose. I know it's not quite the same thing, but anyway. So in this case, we have 7 frames per pose, and we have 8 poses. Just counted that up. Okay, so how do we work out for the object we're looking at from our position and its own direction? How do we work out exactly how this should appear? So what I'm going to do is I'm just going to define a few things. I'm going to call the object I'm looking at object A. I'm going to call the viewer object B. And there are 2 angles that we really care about. We care about the angle from A to B. So in this case, if B is looking at A, it's looking direct. Whereas in this case, if B is looking at A, that's an angle of 90 degrees, and so it's looking at A's side, if A were to look this way, for instance. So we have the angle from A to B, that's important, and the other angle is A's own local direction, where A is looking. So I'm going to call this, I guess, local. So as an example, let's say we're looking at this situation here. I'm going to call theta appearance basically the offset angle, like which thing we should show. In this case, this should be based around 90 degrees. So we should be seeing the side of the monster in this case. Whereas, on the other hand, if we are looking at the monster, but the monster is also looking at us, then we should be looking directly at their face. So theta appearance would be 0 degrees. So here's a formula I'm going to present. I'm going to say the formula is theta appearance is the angle from A to B minus the local rotation. Okay. So then, in addition to that, we need to get the number of degrees per pose, I'll say. And if I were to look back at this sprite sheet, that's basically saying what sort of a range of angles will this, what sort of a range of angles will we represent here? And basically what we'll do is we'll take 360 degrees and then divide that by the number of poses. So I'll call that pose count. It really doesn't matter. So in this case, we have 8 poses. So 360 degrees divided by 8 is 45 degrees. And this is probably a good point at which I should mention that this is just a broad overview of the concept. So in your specific case, you may need to tweak things a little bit, but the idea of this degrees per pose is that this angle here represents basically a range of 45 degrees. So we could go 0 to 45, that would work. We could go negative 22.5 to positive 22.5, that would work as well. But however we want to do it, each of these will represent some viewing range of up to 45 degrees. Okay, now if we know that, we can actually get the pose number that we're looking at. So for instance, over here, I could say this is pose number 0, pose number 1, pose number 2, and so on. Like I said, adjust this to your specifics. So if I want to calculate the pose, I'll call it pose index. Then what I'll do is I will get theta appearance, divide it by the number of degrees per pose. So for instance, if I'm looking at if I'm looking at this monster and I am looking at an offset of 90 degrees, so I'm looking at its side, I take 90 degrees, divide by 45 is 2, and so that's 0, 1, 2. This would be the side that I'm looking at. As I keep saying, adjust this as necessary. Now, what you are going to need to do is you're going to need to turn this into an integer, because we're going to be using some calculations here. Now, it's up to you whether you want to just round it to the nearest integer, round it down, round it up, add an offset, anything like that. It's fine. But finally, we need to get the individual frame number. Now, if we look here, we see that the first pose runs from 0 up to 6, and then the second pose starts 7 frames in. This animation has 7 frames associated to each pose, and so what we're going to do is we're going to take the pose number, multiply it by the number of frames per pose, and that's sort of your offset into the beginning. So for instance, if we're looking at pose index 1, we would be beginning 7 frames in. If we're looking at pose index 3, we would be beginning 21 frames in, and so on. So what we'll do is we'll take the frames per pose, multiply that by the pose index. That gives you your beginning offset, and then onto that we'll add the animation's local frame number. So the local frame number will just be some variable that sort of loops, from 0 up to 6 in this case. So again, we pick whichever pose we want to do. Let's say we want to pick this one here, and then we add some number from 0 up to 6. That will just be addressing this little sub-region of the whole sprite sheet. So I hope that makes sense. Let me just jump in real quick and I'll show you an example of this in action. So this is a game that I made ages ago. Just wanted to put it out there. I really think this is something I got right, this title screen. Looks very cool. But yeah, let's jump into it. Let's see an example of directional sprites. By the way, this is not how you should do skyboxes. It's messed up. Okay, so here we are in a dark indoors level. Good thing I got my flashlight. Doesn't work so well, but anyway. And right down the back, we have here an example of a directional sprite. Based on, which way it's facing and which way I'm looking at it, we see a different side. And this is an example of why it's important to really deeply understand the math behind it, because what I can then do is implement shadows. The way this is working is basically the nearest light looks at the monster, selects the appropriate thing that it sees, and then that is drawn on the ground as a dark copy. And it looks very spooky. Got to get some health. That's better. Okay, so there we have it. In this video, I've talked about the concept of directional sprites, as well as the math for how to calculate the appropriate image to show on a sprite sheet. I hope you enjoyed that, and I've got some tombs to explore. Alright, see you later. Bye.